Hello everyone. Let us continue learning C++ programming. In our previous videos, we discussed about classes, objects, inheritance, and access specifiers, and a very important keyword, which is friend functions, and friend classes in C++ programming. In this part of the video, we're going to discuss about yet another important topic in OOPS concepts, that is polymorphism. But before we get in detail with polymorphism, let us start with the definition of it. The word polymorphism itself is a Greek derivative, which means poly stands for many and morphism, morph stands for forms. So which basically represents many forms. And the entity that can take many forms in C++ programming are none other than functions. So functions can take many forms, such as overloading and overriding, which can be classified by runtime polymorphism and compile time polymorphism. Before we get in detail with polymorphism, it is very necessary that we know the complete details about functions in C++ programming. So in this part of the video, we'll discuss about functions in C++ programming. Let's get started. To begin the proceedings, I'm creating a new file and I'm saving the file as program5.cpp, where CPP is your extension for your C++ programming. And I'm starting with my header file include iostream, which is a necessary header file for C++ programming. And on the very next line, I'm including my namespaces, std, which is used for cin and cout functionalities. And others place, I'm creating a function called add, which returns the addition value, which takes two arguments, int a, int b, and what it does is it adds up the values of a and b and returns the result as your response. Similarly, I'm creating another add function which takes floating variable as the arguments and that returns a and b as well. It can also be even more extended, int add of int a, int b, int c, which adds up all the three values and returns it. Now inside my main function, I'm going to just call these functions with the help of cout statement, cout add of 3, 4, and I'm ending the output with a semicolon new character. So I'll copy paste the same line one more time. So multiple times. So let's have one iteration for a double value 78.98, 12.67. And the next one will take three values, 5, 8, and 9. Now let's compile this code and see what is the output we are getting, for which I'm calling my G++ compiler, followed by the file name program5.cpp -o, followed by the object file name, which is pro5, short typing error, return. Now let us compile it one more time. Okay, so let's spot and fix this error. The error that we had here was earlier. This was the command line we executed. Now we all know there are two types of data types available in C++ programming as well as C programming. which is used to store and retrieve decimal values, and those are float and double. So by default, if I pass a value in the form of decimal as a direct argument to a function, what is the type that will be considered as? And here is an answer for the same. It will by default be considered as double values all the time. Hope this idea is very clear to you all. Any decimal value which is passed as a direct argument to any function or to any part, it will be by default considered as double and not as float, because double is a decimal value data type which has a longer precision than floating variables, because float has only 4 bytes of memory, whereas double has 8 bytes of memory. And in this code, the error what we encountered here is nothing but we had three functionalities, three overloaded functions with the same name of add, and the first function takes 2 arguments and has a return type of integer, and the argument types are also integers. And the second type of overloading again takes only 2 arguments. The only different data types were floating variables. And the third type is completely unique. It has got 3 arguments. Now the conflict that occurred in our program was in our 14th line of the code, when we pass 2 arguments to the function of value 78.98 and 12.67, those values are considered as double values. As you can very well see, they are treated as double values. We don't have any functionality here which has double variables as its arguments and as well as the return type. So that caused a chaos, and that made the compiler to throw an error statement saying that there are overloaded functions here, but having double as its argument. Look at this line. Having double as its argument is ambiguous. It is not found. If there is a case, we have the return type and the argument types of this function to be set as double. Even that suffices the problem here. When I compile it, there are no error statements here. I'll compile it one more time for you to see it clearly. There are no error scenarios. Now let's run the code with the command of pro5, and it very well prints the output as desired. Hope the ideology of function overloading is clear to you all. And this way of performing function overloading is called as compile time polymorphism. And reason because depending upon the signature of the function call, the specific function to which it has to be mapped to is already pre-decided during the compilation time itself. And hence, these types of polymorphism are called as compile time polymorphism. In short, function overloading is an implementation of compile time polymorphism. To add to this detail, there is yet another way we can perform this overloading action. That is, I don't have a function which takes 2 integer variables as its arguments and returns the integer. Rather, I have 3 in place, and I'm default setting the value of C to 0. And I'll clear the screen and compile it one more time and see the response. There are no error messages that is being printed here. But what happens when I call the 11th line and the 13th line? What is the output I'm expecting here? The output is still the same, and the way it responded is very simple. That is, in the third part of this argument, in the third part of this function, I'm providing a default value, and these are called as default parameters. If there are no values provided to the parameter, which is no value passed as an argument to that particular parameter, then that particular parameter will take a default value which is specified by us. In this case, for the parameter C, I'm setting a default value of 0. And during the function call in my 11th line, I'm passing only 2 arguments, namely 3 and 4. So the value of 3 will be assigned to variable called A, and the value of 4 will be assigned to variable called B. Since the value for C is not provided, it takes up the default value of 0. And during the function call in the 13th line, it is perfect. I have got values for all 3 variables, 5, 8, and 9 individually. So it takes the corresponding values to the respective variables and returns the sum of 3 variables as a result. This is yet another form or feature which has to be noted in terms of function overloading in C++ programming. I hope the idea of function overloading, which is a compile-time polymorphism in C++ programming, is clear to you all. See you in the next part of the video where we discuss more in detail about polymorphism and especially the runtime polymorphism, which is called as function overriding. And we also keen on discussing a lot of similarities and differences between function overloading and overriding, which is a very frequently asked question in company interviews as well as your HR technical discussions. Stay tuned. See you in the next part of the video. Until then, happy coding and thanks for watching.